the gradient and equation of a. To review something in book 1 mathematics, that's where the basis of a line is started, and there you given a line to come up with the coordinates, then plot the line. In book 2, we will see it from either angles, with the equation to come up with coordinates and with coordinates to come up with the equations. Therefore, before we get to the equations of a line now, I would like us to know what a gradient is. And we know very well that with reference to the Cartesian plane, a line might not be very straight with no slope. You may find some other lines very vertical, but now there are cases whereby a line is just crossing through any angle, or even this way, Therefore, if a line is crossing this design, we say that it is having a given gradient, and that gradient is the displacement it is having in the y-axis and the x-axis. Therefore, the displacement a line is making, because you find the equation here, you can have xy as a coordinate here, and another point x prime y prime, let me call it that. So you find as you progress on the line, the value of the coordinates is changing. Unlike this one, if we find this is line x is equals to 2, for example, upwards x will remain to be 2. X will remain to be 2, and of course upwards y will remain to be 0. Therefore, if x is 2 for this line, x remains to be 2. For this one, if y is equals to 3, y remains to be 3 throughout. But now in these sloping lines, we say that they have a given gradient. Therefore, we say that the gradient of a line is given by the vertical displacement divided by horizontal displacement by the horizontal displacement. So we are arguing this, that if you have a line with coordinates 1, 3, and 4, 7, for example, this is a line which means that from the coordinates 1, 3 and 4, 7, as you go along this line, it has displaced from 1 to x is equal to 4, and it has displaced from y being 3 to y being 7. And therefore, the rate at which it has sloped, or the gradient, or the slope of this graph, is when we take the change in the y-axis, so change in y-axis, all over change in x-axis. Therefore, it will be 7 minus 3 from y is equals to 3 to y is equals to 7, all over the change in x until x is 4, from x is 1, you see? So 4 over 3. 4 all over 3. So you can leave it like that in this topic. So when you are doing the calculations, the gradient can be expressed as an improper fraction, or even making it a mixed number is not a problem. Therefore, you find now that measure of how a line is sloping or how steep it is, we call it the gradient of the given line. Therefore, generally, we can say that the gradient of a line, let me get a duster, the gradient of a line the gradient of a line is the measure of how sloppy or steep a line is, of how sloppy or steep a line is, given by, so we can say gradient M is given by change in the y-axis or the vertical axis all over change in the x or the horizontal axis. Example, find the gradient of a line which passes through points, and you're given two coordinates 6 and 5, 13. Find this gradient. So the gradient is found by gradient M is found by change in y all over change in x, or simply y2 minus y1 all over x2 minus x1. And the other way around will also be correct, will give us the same answer. Therefore, in this case, we'll get 13 minus 6 all over 5 minus 2, and this is giving us 7 divided by 3. So 7 over 3 is the gradient, or 2 and 1 all over 3, or 2 and a third. So that's how we get the gradient of a line. The change in y all over the change in x. How the y-axis has shifted divided by how the x-axis has varied. So x-axis is varying by 3 units from 2 to 5, and the y-axis is varying from 6 to 13, so 7 units. So that measure of the vertical displacement divided by the horizontal displacement is what we call the gradient of a straight line. Now, we can go to something called now the equation of a line. The equation of a line. It's commonly expressed in the form y is equals to mx, where both m and c are constants. They are constants. Therefore, mostly, though you can be taught to express an equation otherwise, it mostly is expressed this way, with m and c being constants. Therefore, in the first case, we can get the equation of a straight line given 2 points. Given 2 points, for example, find of a line passing through points, and you're given 2 points. Let me get an example of 2 points. You are given 2 points like -1, 7, and another point 3, 3. -1, 7, and 0.33. To find the equation. We first get the gradient m, which is given change in y all over change in x. This will be 3 minus 7 divided by 3 minus 1. So 3 minus 7, 3 minus 1. So this becomes negative 4 divided, simplifying to negative 1. Therefore, now the gradient in this line is negative 1. So gradient is negative 1. Then we take a coordinate, any of the coordinates, and we let another coordinate xy. We let another unknown coordinate to be xy. Then now we re-express the gradient now. We re-express the gradient. We say that gradient is given by y minus y here in 3 all over x minus x here is 3. So this implies that when you cross multiply, this one will be y minus 3, then the other side it will be negative x when you cross multiply, plus 3, negative x plus 3. So now to remain with y on y is equal to negative x plus 6. Because this is 3, this becomes a positive. So this is the equation for that line in the form y is equal to mx plus c. So here it means m is negative 1, m is negative 1, and it gives us the gradient of this line when an equation has already been expressed. Therefore, with this format now of expressing an equation, with this format, the coefficient of x, which is m, gives us gradient, and the constant here x, or c, that is, it gives us the y-intercept, or where the line cuts the y-axis. We can also get the equation of a line. We can get the equation of a line again when given 2 points. That's when given 2 points. Now, when given the gradient and 1 point. Given gradient and 1 point, now this is similar. When given the gradient and a point. When given the gradient and a point, e.g. find the equation of a line with gradient and passing through point. Equation of a line which is having gradient 3/4 and passing through point -1, +3. Solution. The gradient is given already, and the given point, then we let another unknown point to be xy, and now we re-express the gradient. We say gradient is equal to y minus 3 all over x minus -1, which becomes a +1, cross multiply 4y minus 12 is equal to 3x plus 3. So this is 4y is equal to 3x plus 15 when this 12 comes here. Therefore, y becomes 3 all over 4x plus 15 all over 4. So this is the expression of the equation expressed in the form y is equals to mx plus c. Therefore, we should know that when an equation is expressed in the form y is equals to mx plus c, m is always the gradient and c the y-intercept. The y-intercept. C is the y-intercept, while m is the gradient. C is the y-intercept, while m is the gradient when an equation has been expressed in this form. There is something else called the x-intercept. Like us to check it. The x-intercept. So for the y-intercept, we have already said that y-intercept is given by the constant in the equation, the constant c. It gives us the y-intercept. So the x-intercept of a line is always there. Let me illustrate the x-intercept. When we have a line with a certain gradient, then you find that this is the x-axis, y-axis. Line is sloping like this. This is the line 1. So you find this line is cutting the y-axis somewhere there. This point P is called the y-intercept. And at this point, where the line is cutting the y-intercept, x is always 0. Then, where it comes to cut the x-axis, point Q, is called the x-intercept. It's called the x-intercept, where the line is cutting the x-axis. Therefore, we usually say that at the x-intercept, y is equal to 0. So, along this line, x-axis, y is always 0. Therefore, it becomes easier for us now to determine that value of x, where the line cuts the x-axis, when the equation is provided. For example, if we are told for the equation, y is equals to negative x plus 6, find the y and x-intercept. Find the y and the x-intercept. So in this case, solution, we will just state y-axis as the point in the constant part. So it will be 6. And the x-intercept, we say at x-intercept, y is always 0. Therefore, where we have y here, we put a 0. Therefore, we'll be saying y is equal to negative x plus 6. So negative x can come to this side, is equals to negative x, and x will be 6 because the negative cancels out. Therefore, y-intercept is 6 and x-intercept is also 6. So that's how we find y and x intercepts of a line. Now, with the concept of y, then we can easily plot a line in an easier manner than in book 1. The way in book 1 we could get an equation, we manipulate it, we start getting coordinates. Now, to draw a graph or the graph of a straight line, you connect the x and the y intercept. Let me show this with an example. You are told draw the graph of the line. Draw the graph of the line. Draw the graph of the line. Y is equals to negative 2x plus 2. Y is equals to negative 2x plus 2. Solution. So in this case, the gradient of the equation is -2. The coefficient, so gradient is -2, and the y-intercept is equal to 2. Then x-intercept, we say at x-intercept y is 0. So where we have y tunaweka 0. So 0 is equal to -2x plus 2. So this 2 comes here, -2 is equal to -2x, meaning that x will be 1. Therefore, x-intercept will be 1, y-intercept will be 2. Therefore, now to come up with this line, we just have to connect these intercepts, whereby we shall say this is 1, 2, 3, 1, 2, 3. These are the negative, -1, -1. So the y-intercept is at 2. So this is the y-axis, y-intercept is at 2, like that. Then the x-intercept is at 1. So x-intercept is at 1. So the line cuts the y-intercept here and the x-intercept here. Therefore, you just join the two intercepts and you come up with your graph of the line. So that is the line. The line is called y is equal to -2x plus 2. So that's how we plot easily the graph of a straight line, just using the intercepts only. Two intercepts, because we have the concept behind getting the intercepts, then we get them and we come up with the graph very quickly. Let me mention something on parallel and parallel lines and also perpendicular lines. For parallel lines, the gradient is always the same. So if you are told that line 1 and line 2 are parallel to each other, then the two gradients will be the same. The gradient of the first line will be equal to the gradient of the other line. And again, another NB now, another note. For perpendicular lines, the product of the gradients is -1. The gradient of the lines is -1. Therefore, if you have a line 1 with the gradient 3/4, then it is parallel to another line. Then the other gradient, when the two lines are multiplied, they will give us -1. So the other gradient will be -4/3. So if a line is having a gradient and there is another one which is perpendicular to it, then the gradient of the other one is always such that when the two are multiplied, they will simplify to a -1. Or simply, for perpendicular lines, if M1 is equal to A, then M2 will be the negative of the reciprocal of A, such that when we multiply the two, we will get -1. So if I tell you that the gradient of a line is 4, then the other one, which is perpendicular to this one, will be having a gradient which is -1/4, such that when we get -4, then we will get -1. When the two multiplied, we get -1. So that's all about the concepts and the gradient and equation of a line in Book 2 Mathematics. I would like now to crown the topic with 2 or 3 examples depending on time. Let me bring a few examples on the same. Let me bring examples on the same. Examples. We are told a straight line, the first question, a straight line L1 whose equation is 3y minus 2x is equal to -1 meets the x-axis at a point called R. Then we are told part A, determine the coordinates of R. On the same, the coordinates of R. Determine the coordinates of R. Then part B of this question, let me copy the whole question, then we start doing it a bit by bit. A second line, L2 is perpendicular. It's perpendicular to L1 at R. So it passes at R, and there it is perpendicular with L1. Then we told find the equation of L2 in the form. Find the equation of L2 in the form y is equals to mx plus c. Y is equals to mx plus c. A third line L3 passes through. L3 passes through -4, 1 and is parallel to L1 and is parallel to L1 is parallel to L1. Find the equation of L3 and part 2, the coordinates of S, the coordinates of S where L3 and L2 intersect, where those two lines intersect. So let's work on this question. Let's work on this question because we have some space. Let me start here. Solution. Part A. A straight line L1 whose equation is there given meets the x-axis at R. Determine the coordinates of R. Or else we determine the coordinates of where the line cuts the x-axis, or rather determine the x-intercept. Therefore, because x, we have the equation, we can say that at the x-intercept y is equal to 0. Y is equal to 0. Therefore, we take our equation 3y minus 2x is equal to -2, and where we have y, we put a 0. So this implies that 0 is equal to negative, or 0 minus 2x is equal to -2. So x is equal to 1. Therefore, the coordinates of point R is 1 at that point y is always 0. Therefore, we state it as an equation in this case. R is equals to 1, 0. So that's how we state the coordinates of a point. Then we are told a perpendicular line to L1 is perpendicular to L1. A line 2 is perpendicular to L1 at R. Meaning that now we can get the equation for L1 first of all by rearranging so that we may have 2x minus 2 on this side. Then we divide through by 3. Y is equals to 2 all over 3x minus 2 all over 3. So we said when an equation has been arranged this way now, the value here is the gradient. So m1 is 2 all over 3. Now, there is another gradient for L2 such that L2 is perpendicular to L1. And we said the gradient 2 is always the reciprocal of this one. Now with a negative. So, but when we multiply, they will simplify to a negative 1. Therefore, we have a gradient and a point where it passes. It passes point R, 1, 0. So we let another point xy. Then we re-express this gradient now, whereby we say negative 3 over 2 is equal to y minus 0 all over x minus 1. Therefore, cross multiplying symbolize that 2y is equal to negative 3x plus 3. So y is equal to negative 3 all over 2x plus 3 all over 2. So this is the equation for L2. The equation for L2 is this one. Then part 3 or part C, we are told L3 passes through a point negative 4, 1 and is parallel to L1. So if it's parallel to L1, then it means the gradient for M1 for line 3, you can call it M3. So M3 will be 2 all over 3 because they are parallel, and we've said for parallel lines their gradients are the same. Therefore the gradient is the same, like that. With the gradient being the same now, then we can choose the point where it passes, negative 4, 1, and another point xy to calculate the equation of this line, whereby now we will have 2 all over 3 being equal to y minus 1 all over x plus 4. This implies that when you cross multiply, 3y minus 3 is equal to 2x plus 8. So 3y is equal to 2x plus 11. Now simplifying it to the form y is equal to mx plus c, being y is equal to 2 all over 3x plus 11 all over 3. So this is the equation for that line in the requested form. Then lastly, find the intersection point of L3 and L2. So this line and this one where they intersect, we solve the two equations simultaneously. So you see that at that point the two lines are equal. Therefore, if y is equal to this and y is also equal to this, then we can equate negative 3 from and to now over 2x plus 3 over 2 is equal to 2 over 3x plus 11 all over 3. I can use my calculator now. So you have to equate the two lines. This y should be equal to this y. Therefore, we can equate the two parts. So at a point of intersection, then the lines are all equal. We equate the lines. Therefore, in this case, now we can group 2 over 3 plus 3 over 2, and we get 2 and 1 over 16. 2 and 1 over 16, which is 13 over 6. So we get 13 all over 6x. Then now 3 over 2 plus 11 over 3. We get 5 and 1 over 6, which is 31 over 6. 31 over 6. 31 over 6. 31 all over 6. Now, meaning that now x will be this one by 6 over 13. By 6 over 13. Therefore, we get 2.4 as x. And now, to get y, we replace x in the equation, in any of the two equations now. So to get y, we'll have 2 over 3, or 3 over 2 for this equation. Then x is 2.4 plus 3 all over 2. And this becomes by 3 negative 3 all over 2. Then plus 3 all over 2. So this becomes 2.01, negative 2.0, 2.1 that is. So the coordinates now will be x 2.4 and y 2.1. So that is the point where the lines intersect. That is the point where the lines intersect. You solve the two equations simultaneously. Because there is some time, let me give out another question. Let me give out another question. Or two more. It's also good to note that when the x-axis is making an angle with a line, let me put that one on board. When a line and the x-axis are making sort of a line here, we said that if you are told that this line with the x-axis are making an angle, then this angle, you'll find that now we have this displacement here and this displacement here giving us a gradient. Therefore, the y displacement all over the x-axis displacement, they give us the gradient. Meaning that because they are giving us the gradient, we remember again in the next topic now in Form 2, where we discuss trigonometric ratios, there is the tangent of an angle theta, which is given by the opposite for a right angle triangle all over adjacent. Therefore, with this acute angle here made by the x-axis and the line, then we can say that the tangent of the angle is equal to the gradient. Because the gradient is also given by the vertical change all over the change in the horizontal. Therefore, we can say that tan is equal to gradient. The tan of an angle here made by the x-axis, the y-axis is always equal to the gradient of the same line. Let me give now the other question I wanted to give. When you are told a line L passes through points negative 2, 3 and negative 1, 6, and perpendicular to a line and perpendicular perpendicular. So a line L and perpendicular to a line P at a point -1, 6. Now part A, find the equation of L. Find the equation of L. Part B, find the equation of P. Find the equation of P in the form y. Okay, in the form now, the form is ax plus by plus c plus by is equal to c. Is equal to c. Given that another line Q, is parallel to L and passes through, is parallel to L and passes point 1, 2. Find the x and y intercepts of Q. Find the x and y intercepts of this other line Q. Then lastly, find the point of intersection of lines P and Q. Find the point of intersection of line P, of lines P and Q. Yeah. Lines P and Q. Lines P and Q. Let me get my refilled biro pen for this one, or I just fill the one I have here. So we are getting, first of all, the equation of a line with two coordinates given. The two coordinates provided for us. Two coordinates are provided for us. And again, the equation of another line now, which is perpendicular to the equation we will have found there above, meaning that the question is just getting an answer, and the answer will be relied upon for the response of the next question. So that's why I usually advise learners to be very careful while solving these type of questions, because you find the answer you're getting in A is being relied upon for the response of question 2. And now if you were wrong in question 1, the error is transferred in question 2, then it means you proceed with wrong things. You get no marks. You get no marks. Solution, or we can start here because of space. There is space. Solution. Now, a line L is passing through those points. Find its equation, part A. We can get first of all the gradient for equation L. And L, 6 minus 3 all over -1 minus 2, which is equal to 3 all over 1. So the gradient is 3 for this line. So with the gradient 3, we take any of the points, -2, 3, where it passes, and we let another point to be xy. We let another point to be xy. Therefore, we express now the gradient is equal to y minus 3 all over x minus -2 becomes +2. So this implies that now y minus 3 is equal to 3x plus 6. So y is equal to 3x plus 9. 3x plus 9. When we take 3 to this side, it becomes a positive. Like that. Again, at that note now, when you express an equation in this form, we said this is the y-intercept and this is the gradient. So you see, automatically the gradient is bringing itself here again when you rearrange. Part B of the equation, find the equation of P in the form, this one, in this form. The equation of P. Now, P is perpendicular to L at this point. At this point. Therefore, if the gradient of L is 3, then the gradient for P will be the reciprocal, now with a negative. In case it was with a negative, the other one now becomes without a negative. Therefore, we have this point where it passes negative 1, 6, and we let another point xy, another common point xy. Therefore, we re-express negative 1 over 3 is equal to y minus 6 all over x. Minus 1 means plus 1. So cross multiplying, this implies that 3y minus 18 is equal to negative x minus 1. So 3y is equal to, okay, there is the form we've been told to express into. So we are expressing in the form ax. So the term with x, negative x, when it comes here, it becomes positive x, then plus y, and y, 3y. And the other parts now go to the other side. So negative 18 becomes positive. Positive 18 minus 1 becomes 17. So this is the equation in the form which it has been demanded in. So that's how we down the equation. That's how we put down the equation. There is another line now which is parallel to L, parallel to line L. So if two lines are parallel, we say that the gradient of one, the gradient of L will be equal to the gradient of line Q, which means 3 for this case, which means 3, Therefore, we are taught to find the x and y intercepts of Q. Meaning, for Q, we first of all get the equation. So they share the gradient, and line Q passes through point 1, 2. So point 1, 2, we let another point xy. Therefore, now we can express the equation for like the gradient 3 is equal to y minus 2 all over x minus 1 all over x minus 1. So cross multiply, y minus 2 is equals to 3x minus 3. 3x minus 3. So in the form y is equals to mx plus c, we will have 3x, then minus 3 plus 2 becomes minus 1. So with the equation now expressed in this form, then we can get the y-intercept, automatically as negative 1, or written as a coordinate to be 0, negative 1, because at the y-axis x is always 0. So as a coordinate, it's expressed this way. And the y-intercept is simply negative 1. Then x-axis, we say that at x-axis, y is always equal to 0. So for this equation now, where we have y, we replace with a 0. So y, you put a 0, is equal to 3x minus 1. So 1 is equal to 3x. So x is going to be 1 all over 3. X is going to be 1 all over 3. So a third x will be a third. X will be a third. Then lastly, on the same question, we are trying to find the point of intersection of P and Q. Line P and Q. So the equation for P, okay, for Q, we found it here. And for P, we have also done it here. Therefore, we say that at the point of intersection, the two equations are equal. The two equations are equal. So we solve the two equations. X plus 3y is equal to 17 and y is equal to 3x minus 1. We solve them simultaneously. So we can use substitution method. We can use substitution where we shall say that because y is expressed directly here, where we have y in the second one, we use this expression. Therefore, we shall have x plus 3. So instead of y, we have 3x minus 1 equal to 17. So we'll have x plus 9x minus 3 equal to 17. So 10x is equal to 17 minus 3, and the 3 becomes positive to that side, so 20. So x is equal to 2. If x is 2, then y will be 3 into x, which is 2 minus 1. So 6 minus 1, we get 5. Therefore, the body for y are here. Therefore, the point of intersection, if we call it point, they are meeting at point Z, then Z will have coordinate 2, 5. That's how the point of intersection is calculated. So I advise learners to pursue more of these examples because questions on the equation of a straight line are frequently tested. Rarely they miss in a KCSE paper. Therefore, solve as many as possible, and I believe that you shall become better students as you try more examples. So the more examples you do, the better student you become. Thank you very much for choosing our channel. God bless you. God keep you safe. Thank you.